dive into it. So in this case, we will have z equals a plus bi, and then as I will be representative of the square root of -1. As an example problem, we have the square root of -9 times the square root of -1. After you do the square root of -9, it'll be square root of 3, and then those two will equal 3i. In a coordinate plane example, how these things intertwine with each other. For the x-axis, this will be the real number, and then for the y-axis, this will be our imaginary number, or as you would have on here, just for consistency purposes, it'll be I. So if we go over, say for instance, we look for this point right here, and say this point would be 4, 5. Sorry for the scribbles. We'll go over on the real axis, we'll go over 4 spaces, and then we'll go up 5 spaces for the imaginary.
To build on to what Terrell was saying, I also drew a coordinate plane here with our x-axis representing our real values, and then our y-axis representing our imaginary values. And for all intents and purposes, I also drew a triangle with, our x-axis being our horizontal, our y being our vertical, and then r being the hypotenuse of the triangle. And the whole bread and butter of DeMoivre's theorem, I'm calling him Demo, I'm tired of butchering his name, is this x plus yi. And to use our trigonometric values to derive our trigonometric values to get x plus yi, we know that cosine of theta equals x over r, sine of theta equals y over r. And to pretty much get x and y, we would pretty much bring the x out here and multiply r and cosine to find x. And then the same with y, we would bring the y out, multiply r and sine to get y. And if we move over here, as you can see, we have z in place of our final answer equaling x plus yi. And if we plug in our trigonometric values to substitute for x and y, we have z equaling r cosine theta plus I r sine theta. And remember, we have our I here just because I is our imaginary number of square root of -1. Because if you calculate that, you don't have anything. She doesn't exist. And for Julio's example, his example has an exponent in it. And as you can see, I have z of n with n representing the exponent equaling r of n times cosine theta plus I sine theta. And we're pretty much going to use our FOIL method to bring our r of n and multiply it by cosine theta and I sine theta. And from here, I'm going to pass it off to Julio.
Welcome. This is going to be the applications / exercise part of the DeMoivre's formula for our project. And now I'll be explaining how to solve this equation using the DeMoivre's formula. As we can see, we have -4, which is going to be the real part given by the x-axis, plus the 4i, which is going to be the imaginary part in the y-axis. And we're given the 6, which is going to be the n, as it is the exponent. Now, the first step we're going to do is solve for r. And as we know, r squared is going to be equal to x squared plus y squared. And following this formula, we find that r is going to be equal to the square root of -4 squared plus 4 squared, which in this case is going to be square root of 32, which simplifies to 4 rad 2. Now, the other part that we're missing still is going to be theta. And for theta, we can use the following. We're going to use this identity, which is going to be the cosine of theta equals x over r. And we already have all of that. So, the x is going to be the -4, and the r is going to be this part, which is going to be the 4 square root of 2. And we can simplify this into being -1 over square root of 2. Or if we wanted to write it other way, it would be square root of 2 over 2. And we can now solve for this. So this is going to be theta. It's going to be equal to this, the cosine inverse of -2/2. And if you were to put in a calculator, you would find that the angle is 3 pi over 4. Now that we know our r and theta, we can finally solve for this. So this equation is now going to be equal to 4 square root of 2 elevated to the 6. As we know, the n is going to be 6. Cosine of 6 times theta, which is going to be 3 pi over 4, plus I sine, once again, of 6 times the theta, which is going to be 3 pi over 4. And we close it. You can plug this number into a calculator. That's going to be easier. And the result is going to be 32,768. And cosine, that's going to be 6 times 3 is 18 over 4. It's going to be 9 over 2. 9 pi over 2 plus I sine of same thing, 9 pi over 2. Now, when we want to distribute, we'll multiply this part first and then this one. Now, when we think about this one, the coterminal angle is going to be at pi over 2, in which cosine is going to be 0. So if you were to multiply this number, 32,768 by 0, it will give you 0. And now, when you multiply by this one, same thing, it's going to be the coterminal angle is going to be pi over 2. But in this case, sine is going to be 1. So if you were to multiply this whole thing across, the answer would be 32,768 I. And now the answer for this is going to be 32,768 I.